Grumman produces electromagnetically formed EMF torque tube assemblies that are stronger, lighter, and more fatigue resistant than those produced by any other method. This means a superior quality product at a lower life cycle cost. Torque tubes are used in high-lift control systems of military and commercial aircraft. Grumman's F-14 Tomcat, for example, uses torque tubes in the leading edge slat and trailing edge flap systems. To ensure a dependable and long service life for a torque tube, a strong, consistently reliable, fatigue-resistant joint must be formed between the tube and its end fitting. Long life is particularly important today as the average age of military and commercial aircraft in service is being extended due to the cost of replacement aircraft. Since 1972, Grumman has produced EMF flight control push rods for primary and secondary flight control systems for all of its aircraft. A natural extension of this technology is the electromagnetically formed EMF torque tube. The EMF process, in conjunction with the Grumman patented end fitting groove design, produces torque tube assemblies with static and fatigue properties that are far superior to all other approaches. Loads, like those imposed on torque tubes during high G maneuvers, takeoffs, and landings, may cause the conventionally assembled torque tubes to fail prematurely. The two conventional methods used to secure the tube to the end fitting to produce a torque joint, riveting and crimping, both have significant drawbacks. Riveting is expensive and labor-intensive. It requires a thicker, heavier tube to avoid elongation of rivet holes, which also adds weight to the aircraft. There are often 8 to 10 rivets required to secure the joint. Even then, in-service stresses often cause the joint to loosen, because it is unlikely that all rivets will uniformly share the imposed load. The riveted assembly fails by elongation of the rivet holes. Crimping also has serious drawbacks. Epoxy is first applied to add strength to the joint. Then, the tube is slid over the end fitting. The tubes are then mechanically crimped into the fitting using crimping jaws. Because of the elastic property of metal to partially return to its previous shape, called springback, the conformity of the crimped tube to the grooves in the end fitting is marginal at best. The crimp joint fails by local cracking in the crimp section. Unequal load distribution will cause joint loosening and will affect the fatigue strength of the crimped joint. All of these factors cause wide variations in joint quality among finished torque tube assemblies, which lead to premature service failures. However, there is a better way. The product of 15 years of company development, Grumman's electromagnetically formed torque tube does not suffer from the drawbacks of either riveted or crimped tubes. This is an enlarged cross-section of the Grumman patented groove profile. The groove profile is designed after determining the torque tube wall thickness and diameter required from specified loading conditions. The outer radius, ramp angle, base radius, groove width, and depth are optimized such that the joint formed by the tube and the grooved fitting will always be significantly stronger than the basic tube. The tube thickness need not be increased by the local stress at the joint, thus resulting in an overall lighter assembly. The Grumman expertise in developing an optimum groove profile, plus the unique advantages of the electromagnetic forming process, results in a lightweight torque tube of superior strength. Electromagnetic forming is an automated process. Torque tubes are produced quickly, at low cost, and are of consistently high quality. The operator positions the tube into a coil and inserts a grooved end fitting. The chamber closes. At the push of a button, The part is formed. Now, let's take a look at how the process works. When the capacitors discharge, they send a pulse of energy to the coil, which creates a magnetic field that quickly builds in intensity. At the same time, a secondary magnetic field is created by eddy currents. The opposition of these two fields generates an explosive force in the coil that forms the tube into the Grumman design grooves in the end fitting, creating a strong, high-reliability, fatigue-resistant joint. The entire process takes place instantly. This cross-section of an actual electromagnetically formed torque tube shows how well the process does the job. Note the tight, close conformance of the EMF tube to the grooves in the fitting. Residual compressive stresses increase joint strength while eliminating spring back. The result is a high-integrity joint without rivets, adhesives, or mechanical crimping. Fatigue life of the torque tube will exceed by many times the number of cycles required of it in service. Static tests have shown the joint to be stronger than the basic tube. Grumman is working to further extend this technology. The company is developing a patented process to eliminate the need for grooving the end fitting, saving the cost of machining. In this method, a grooved mandrel is inserted into the end fitting, which is then inserted into the tube. When the coil fires, it simultaneously forces the tube and cylindrical end fitting to conform to the shape of the grooved mandrel forming the joint. The mandrel is then removed and reused. The new process has other advantages too. For example, an end fitting of relatively thin wall can be used, as opposed to one that requires extra thickness to accommodate the machining of grooves. This technique results in a savings of both cost and weight. Extensions of technology such as the patented torque tube fitting groove design and innovations like the patented conformal torque tube approach are part of a continuing program to technologically enhance the electromagnetic forming process. Grumman has been a leader in EMF since 1972, when they first introduced EMF flight control pushrods for Grumman aircraft. The patented EMF groove design is widely applicable. Grumman is studying applications of aluminum drive shaft technology for the transportation industry. Commercial and military aircraft companies have expressed interest in Grumman's patented electromagnetically formed torque tube designs, and in-service flight tests are already in progress. The F-14D will employ the first EMF torque tubes for military application in its high-lift systems. Grumman wants to work with you on your torque tube requirements. We can provide EMF torque tubes for either new or exact replacement applications. Either way, the Grumman EMF torque tube will provide you with a superior product, one with longer life and at lower life cycle cost.